Good afternoon. So today we are going to discuss about Dijkstraws algorithm. Dijkstraws algorithm. So what are the inputs? N. N is the number of vertices in the given graph. So W is the cost adjacency matrix. So it can be read through matrix. S is the source. Source means, for example, A. The source, because it is called a single source. Okay. Shortest path algorithm. Next, destination means, so whatever the vertices we consider, okay, first we consider A as a source, okay, so then that A becomes destination. D is the shortest distance from the source to destination, and P is the shortest path. Okay, so how we do is, so initially we go for loop, means we have to categorize into the vertices that we have visited and the vertices that we have not visited. So initially, if you consider this graph, so we have not visited any vertices, so S is 0 and V minus S belong A, B, C. Okay, so these are the vertices that comes under B minus S, because all the vertices are there. Now you take one source A as the destination, A. Okay, we admit that. Okay, we make it as S. Okay, so the remaining vertices in B minus S is B and C. Okay, so now initially for this loop, I is equal to 0 to n minus 1 means all the vertices that you consider. So d of I, the distance, is taken by the cost, because we are going to read it from the cost matrix. So whatever the source, from source C, for example A to B, okay, the cost is 1. Okay, so that will be taken as the distance. Then path. The path is thing that taken from the source. So initially for A itself is the path. Okay, and initially S of I, okay, so is 0. This indicates whether we have visited or not. Since we have not visited any vertices, it is 0. Now we have visited the source, so make it as 1. So we are considering this as the source now, so make it as 1. Once we visit, we make that as 1. Okay, now there is one more loop. So here what we are going to do is, we are going to consider the shortest path from A. Now we have visited A. Okay, so what is the distance from, what are the vertices that are connected to A? B and C is connected. Okay, so A to B is 1 and A to C is 5. Okay, so you select a destination which is shortest. So now B is having a weight 1, so that is the shortest distance. So you are going to admit B. This you are going to do until you get the destination. Okay, so now here B is the destination, because this is the shortest, so you are going to stop it. Now meanwhile, so this is okay for the vertices that are connected. Now take for example C. Even though it is directly connected, this is not the shortest path. Okay, the shortest path is given through B. Okay, so B, to reach C from A, it is, you require 1 plus 2, so 3 is the minimum cost. Okay, this is shorter than this distance, 5. So that's why we have to consider U in such a way that it should be less than d of V, the distance. See, d of V, let us take for example A to C is 5. Okay, d of V is 5. But there is a new path which is after reaching B. Okay, So now that you have admitted u, b, okay. After that, what happens? So d of u is equal to 1 plus, wait, 2. Okay, so that means 3. So this becomes your new destination. So admit C. Okay, so C, that is the shortest path now, T of V. So P of V, that is the path is through U, means now you have admitted to reach C, you have to go through B. Initially it was A, okay, but now the new path is B. Okay, the shortest distance from A to C is through B. That is the meaning. Okay, so like this you are going to repeat this till you have all the vertices visited. Okay, so initially all the vertices you are going to visit. Now there is 3 vertices, A, B, C. So all the 3 we have visited. Okay, so we are going to stop the algorithm. So let us discuss about the problem on Dijkstraws algorithm. So the problem is there is one source and we have to find the shortest distance to other vertices from the source vertex. Okay, so we have to find the shortest distance from A to B, we have to find the shortest distance from A to D, to find the shortest distance from A to C and A to E. So this is our objective. So some of the applications of this Dijkstraws algorithm is, so I'm sure everyone is using Google Maps. Okay, so this Google Maps works based on Dijkstraws algorithm. Suppose if you ask the shortest path between 2 locations, so it is going to internally use the Dijkstraws algorithm and find out the shortest distance between 2 locations. So here we have to classify the 2 columns. One is visited, another one is unvisited. First you have to always take the source. So that is A, and A doesn't have any source, and you can take the distance as 0. From A, what is the distance of other vertices? So let us take B. B is not connected to A. See, this is not a, this is a directed graph. Okay, so that means there is a connection from B to A, but not from A to B. Okay, so it is A, B doesn't have any source and the distance is infinity. Similarly, if you take D, but D is connected to A. Okay, so the source is A and the distance is 7. Okay, so next if you take C, C is not connected to A, so it is, take it as dash, and again E is also not connected to A, so you can take it as dash and infinity. Now among this is infinity, this is infinity, and this is infinity. So the shortest distance is D, and its source is A and the distance is 7. So that means we are admitting this. So now we make this is as considered as U, means new vertex is added. So that means from this column we are admitting to this. Okay, so V minus S now will remain only with C and E, okay, and B, because D is admitted to this visited. It belongs to S now. So now take D with the source as A and distance as 7. Now again we have to find the distance. Now that means now we have reached D. Okay, from D we have to find the shortest paths to the other vertices. Okay, so now let us take B. See here, initially B was infinity, but now after reaching D there is a connection from D to B. Okay, so B 7 plus 2. Okay, so the source is D and the distance is 7 plus 2. Now D is, we don't have to consider. Again C. C is also connected to D, so it is 7 plus 5. So the source is D and the distance is 7 plus 5. And here E is not connected to D. So we will retain this as infinity. Now if you look at this, it is 7 plus 2 9, this is 7 plus 5 12. So this one is the shortest. Okay, so that means now we have got the shortest path to B. And what is the source? Means the shortest path to B is via D. Okay, the source is D, and for D the source is A. That means the shortest path to B is ADB. Okay, and the distance is 7 plus 2 9. Okay, so now again we have to consider the remaining vertices. So C, now after reaching B, so let us check whether it is possible to reach C. So C, yes, it is possible from B. So B, it is 9 plus 4, so it is 13. Okay, but whereas here it is 7 plus 5 12, so this one is the shortest, so retain this. That means for C the source is D only and the distance is 12, so don't change that. Okay, now we are left with E. So after reaching B, E is not connected, again it is infinity only. Okay, now this one is the shortest. Okay, this one is the shortest, so admit that. Now C, D is the source and 12 is the shortest. Okay, now if you once we reach C, okay, so we can reach E. E is connected, so E, the source is C, and for C it takes 12 plus 6. Okay, so now we are left with only one vertices, that is E. So E is equal to, and the source is C and it is 18. Okay, so now we have the path for all the vertices. So from A to D the source is A, okay, and the distance is 7. From A to B the source is D. Okay, so the distance is 9. So for E the source is C. For C the source is D. For D the source is A. So that means the path is A D C E. A D C E. Okay. For B the source is T. Okay. For D the source is A. So the path is A D B and the distance is 9.